Hello, everyone. Today we're going to be talking about finding the line of best fit. And basically, what we're talking about when we are discussing the line of best fit, we're talking about fitting a line to any set of data in order to make predictions about that data. So you should have already gone through scatter plots, and we talked about that in real world situations that not everything is going to fit into a nice linear pattern and a nice linear constant rate. So sometimes when we have things that are relating, they will make a cluster that looks like a linear pattern, but it won't necessarily be an exact line. In that scatter plot, we're going to talk about how to fit a line to that scatter plot. So I've got Desmos pulled up here on the side so you can follow along on how to do that. And remember, Desmos is free online. You just got to go to the website. So we have a table that's comparing the calories and the fat of meat and fish. So we have fat grams to calories, and we're going to graph this by hand first and just kind of look at it and see what type of pattern it's making and just kind of look at what type of function we possibly can have, and then we'll look at it in Desmos. So of course, as I'm comparing here, I see down here on the bottom, I have my X value is my fat grams, and I have my Y value is my calories. So we're trying to see if there is a relationship between the more fat something has, the more calorie it has. So we're just going to start plotting these points, and I'm looking, obviously I'm going to have to estimate a little bit, but I'm going to plot the points all the way through. All right, so I just kind of did a fast forward here after I plotted my points, and you can see that my points are not perfect. I had to estimate, but the point that I wanted to make with plotting these is that you can clearly see that they are making a linear pattern. There is a linear cluster that as the fat increases, so do the calories. So what we want to do is we want to actually make some observations and find the line of best fit and use that line of best fit to make some predictions. So the first question says, what function best models this graph data? So as discussed just a second ago, I think we can all agree that this is linear, that we would be drawing a linear function through those points. Does this relationship have a negative, positive, or no correlation? So negative correlation means that as one increases, the other one decreases. Positive means as one increases, one increases. And then no correlation means it wouldn't have a pattern at all. It would be scattered everywhere. And I think we can agree that when looking at this, that as my fat increases, so does my calories. So this is going to be a positive relationship. And then it asks, is this relationship strong or weak, and how do you know? So strong or weak, you can actually determine this exactly using a correlation coefficient, but that'll be in another video. But just by looking at this scatter plot, I can determine that this has a strong relationship. And the reason I say it has a strong relationship is because my data points, my scatter plot has values that are compacted close together. And because they are compacted close together, that means that they are going to have a strong relationship. The more spread out they are, the less of a relationship they're going to have. The more compact they are, the stronger the relationship. So I'm just going to put that it is a compact pattern. Okay. Now what they want us to do is they want us to find the line of best fit. So I'm going to look at Desmos, and I'm actually going to talk about how to put this in a table into Desmos and go through the process. All right, so the first thing that you're going to do is you are actually going to click the plus button using Desmos, and it's going to give you some options. Now, if you're using the NC test version, you should only see two options. If you're just using the Desmos.com, it's going to give you a lot more options. I recommend only using the testing version. And the reason I recommend that is because that's what you'll be used to if you have to take your final exam. So for the table, I'm going to add that in, and it's going to give me an X1 and a Y1. So in my X's, I'm going to put in all of that information. And then I'm going to go back to the top, and I'm going to put in my Y's. Now, I've got all of that information put into my table, but I don't see any points up here in the actual the graphing section. And if you look at the scale says that it's a 10 by 10. And of course, I'm not going to see my scatter plot if I'm talking about calories that are up in the hundreds. So here's the great option that's in Desmos. It will automatically scale this for you. So if you look down at the very bottom, you should see in the blue section, you should see that zoom symbol, that magnifying glass with a plus. That will automatically zoom your scatter plot for you. So if you click that, and there's my scatter plot. Now, your scatter plot should look very similar to something that you did. Now, is it going to be perfect? Again, that's a no because you estimated. But you should now see your scatter plot zoom for you. And you can see the scale has drastically changed so that my X values are ranging to the 30 range, and my Y values are ranging above 200. So how do we find the line of best fit? So to find the line of best fit, we are going to use our y equals mx plus b model, our slope-intercept form, okay? The only thing that we're going to do is we're going to alter it to fit Desmos and finding the best fit. So when we type that in, we're going to use our keyboard, and we're going to type y and 1. Okay, so why are we typing y1? Because the y1, or the table, was labeled y1. Now, we're going to use the similar symbol. I actually call it the squiggle in my class because that's how the kids remember it, but that's under your keyboard. So it's just a squiggle mark. And then I'm going to type MX, and I need to do another 1, and it's going to automatically put it in the subscript for you. Remember, we're doing X1 because that's the way the table is labeled, and plus B. Now, in doing this, you should automatically see your line of best fit show up, and you should see that line that goes through those points. Now, here's the great thing, is if you look, it tells you your M and your B. So I now know that my M in this problem is 10.450. I always like to use 3 decimal places to get a very accurate prediction. And my B is 68.113. So I'm going to use those, and I'm going to write my line of best fit. So I have y equals, my M is 10.45 x plus 68.113. That is my line of best fit. So this is telling me that for my slope, I have 10.45. That's telling me as my calories increase around 10 to 11 calories, that means that my fat grams is increasing by 1. And then my y-intercept is around 68.113. So now what they want us to do is they want us to make a prediction. So that prediction is asking me how many calories will I have if I have 28 grams of fat. So for 28 grams of fat, I should see that 28 grams of fat is an X value. So we're going to take, 26 grams of fat. We're going to take that and we're going to plug it in to my equation for my X value. All right, so I'm going to have y equals 10.45. I'm going to insert and substitute 26 in for X. And that's plus 68.113. And I'm going to calculate that, and I can do that right in Desmos. I can go to the next row, and I'm going to type in 10.45 times 26 plus 68.113. And I get approximately 339.8 calories in 26 grams. So I'm predicting that. Another way that I could do this is if I know that I'm looking for 26 grams of fat, so X would be 26. In Desmos, I could say X equals 26, and I could find that intersection. So it just graphed that line in green for me, And again, that intersection comes to 339.8. So there's multiple ways of looking at this. You can do it by hand. You can find the values in Desmos, but ultimately the line of best fit is going to help you make predictions given some real world application data.